We were talking about graphing simple rational functions, and the graph of a rational function in the form of y equals a divided by x, y equals a divided by x minus h plus k, and y equals a times x plus b divided by c times x plus d. If you look at these in each one of these forms, we notice that the variable is in the denominator, and so that puts some restrictions on our domain. So a rational function, an equation in the form r of x equals p of x divided by q of x. So we have a function divided by a function, where p of x and q of x are polynomial functions, and q of x cannot be equal to 0. So that means that function, the denominator, cannot be equal to 0 because we cannot divide by 0. So the denominator can never be equal to 0. Where the denominator is equal to 0, there is a vertical asymptote. So right here, we have a vertical asymptote wherever the denominator is equal to 0. We're going to talk about 3 different forms. We're going to talk about the parent function, and the parent function is f of x equals 1 over x, and that takes the shape of a hyperbola, which we'll look at in a minute. There are 2 symmetrical branches, and for this parent function, the domain starts at negative infinity, goes to 0, not included. Union starts at 0, not included, goes to infinity. Same thing for the range. We're also going to talk about translating simple rational functions. See, we have the h and the k. You're going to draw the asymptotes where x is equal to h and y is equal to k. Remember, the h is backwards because of that minus sign that's in the equation. When you go to graph this, you'll plot points to the left and to the right of the vertical asymptote, and then draw 2 branches of the hyperbola so that they pass through the plotted points and approach the asymptotes. There'll be one more version that we look at. F of x equals a times x plus b divided by c times x plus d. The vertical asymptote of the graph is wherever the denominator is equal to 0. So when you go through and do the math, you set this bottom equal to 0. So first thing, you'd subtract d, then you'd divide by c. So basically you end up with the equation of x equals negative d divided by c. The horizontal asymptote is where y is equal to a divided by c. So basically you take the lead coefficients up here, whatever the lead coefficients are, a divided by c, and that is your horizontal asymptote. So we have the parent function graphed here, y equals 1 over x, and that's the blue function that's graphed here. And you can see that there's 2 spaces where there aren't any points. Right now, there's the point x equals 0, and then there's the point y equals 0. Maybe we can see those a little bit better. We can also translate the function a little bit. So what happens to the function if we say we subtract 2 from x in the denominator? You can see that the asymptote goes from x equals 0. Now it changes to x equals 2. You can see that it gets changed and shifted over to the right. Even though the function has a minus 2 in it, it's still going to shift to the right. Now, when we do the plus k, let's say minus 3, that shifts the function down, and so that ends up telling us that our asymptote will be at negative 3, which is down here. So we can see how the parent function was shifted to the right 2 and down 3. We graph those 2 asymptotes, graph 2 or 3 points to the right, 2 or 3 points to the left, and then we can see that it gets really close to the asymptote as we go. We can turn these ones off, and we can take a look at this function here, which is 3 times x plus 2 divided by 2 times x minus 6. Now, for the vertical asymptote, what you do is you take this bottom and you set it equal to 0. So right here we would say 2x minus 6 and you set that equal to 0. So the first thing you do is you add 6 to both sides and you divide by 2. And then what you get for your asymptote is you get x is equal to 3. So we see that we have that vertical asymptote right there at x is equal to 3. For the horizontal asymptote, what you do is you take the lead coefficients. In this case, we have 3x and 2x, and you just divide them. So 3 divided by 2 and 3 divided by 2, we have the horizontal asymptote there at 1.5. And that's all set. And we can zoom out a little bit just to show that we have those asymptotes that the graph is never going to cross as we go closer to infinity in all the directions.